Hey, what's going on, everyone? Homework assignment 48. Today's objective, I could find missing measures of similar figures. Missing measures of similar figures. Similar figures. Here's our vocabulary. Similar figures are figures that have the same shape, but not necessarily the same size. Same shape, but not necessarily the same size. Okay? Can similar figures be the same shape and the same size? Yes, they can. Remember, we call that congruent. If they're exactly the same, then we call them congruent. But if they are the same shape but different size, then we would call them similar. Corresponding angles. In similar figures, corresponding angles are congruent. And when we say corresponding angles, we're going to get used to seeing a lot of different drawing terminology. When we say corresponding angles, we mean the angles that are on the same side of similar, or the same corners of similar triangles, similar shapes. So for example, normally if we were in a classroom, and I'll have us do this tomorrow, if everyone was to lift up their right hand, if everyone, picture this, you're lifting up your right hand and it's facing the board. So it'd be facing me, the teacher, in front of the room. Everyone who lifts up their right hand, their thumb is in the same position. All of their thumbs are in the same spot on your hand. So we could say that our thumbs correspond to each other. So our thumbs on our right hands all correspond to each other because they're all in the same place on our right hand. No matter what we do to our right hand, even if we turned it around and had it face the back of the classroom, our thumbs are still in a similar position than every other student's thumb on their right hand. So all of our thumbs correspond to each other. Okay, so corners or angles that can correspond to each other, if we take a look here, would be like angle A and angle X. Both of those angles are in the same position on two different triangles. Angle B, notice that there's two lines to note that angle B is the same as angle Y. And three lines, angle C, denote that they are the same as angle Z. Okay? So though all of those angles correspond to each other. So this is what we say. So here's what the symbols mean. Triangle ABC, because when there's a little triangle, it's saying triangle ABC. The little squiggly is similar to triangle XYZ. So triangle ABC is similar, because remember this means similar, to XYZ, to triangle XYZ. Okay? Then it's also saying that angle A, all right, that's a little symbol we're going to use for angle, is congruent to angle X. So angle A, remember we said before, is congruent to angle X, meaning they have the same exact measure. Angle B is congruent to angle Y. Angle B is congruent to angle Y. And angle C is congruent to angle Z. Okay, so a few new terminology shown. I want to say terminologies, but a drawing sketches shown to show what's going on here, okay? If this is the case, then we could say, because notice now we get to what we're talking about. We're talking about proportions. If our two triangles are similar to each other, then we could say that AB, which is this line, all right, AB is AB is similar to XY. All right. BC is similar to YZ, and AC is similar to XZ. Okay, and these will all be in proportion to one another. So make sure you have this diagram down. If it's easier for you to pause it, kind of take a screenshot and print it, you can do that as well. All right. So similar idea over here. We have two shapes, and we're being told that they are both similar to each other. ABCD is similar to figure EFGH, okay? So they're similar to each other, and the way that we know that is they told us there, and we have this little squiggly sign in between. That means that they are similar, okay? So at the bottom it says similar figures have corresponding parts. Remember what we said about people's thumbs. Our thumbs on our right hands all correspond to each other. They're all in the same position. So similar figures will have corresponding parts. These are angles and sides in the same position. Okay, so as we stated before, angle A and angle E are corresponding. Notice that they are kind of that smaller angle angle C and angle G are corresponding. Actually, they're probably the smallest angle. It kind of comes to a point there, kind of like the tail of a kite. Angle B and angle F are corresponding, and angle D and angle H are corresponding, okay? So with all of the angles that correspond, then we're also going to have corresponding sides. It states here AB and EF. So line AB and EF correspond to each other. CD and GH. BC and FG, and AD and EH, or DA and AG. Okay, so just getting into the idea of corresponding. Now, I'm going to show you two examples. One is going to be pretty straightforward. The other, we're going to have to focus on what we mean by corresponding. Okay, so here are the two models that I'm giving you. So we're given figures, we're given similar figures. So we're already told that these two triangles here are similar to each other. So what does it mean if the triangles are similar? Well, it means that their corresponding sides are going to be proportional to one another. Okay? So notice just from the angles. So notice my angles are in similar spots. A has one line, C has 3 lines. Okay, D has 1 line, F has 3 lines. Nice. Okay, so this is going to be a nice easy one for us. Okay, so what we're saying is that line AC, which is this line right here, corresponds to line DF. All right. We're also saying that line BC, let me change up my color actually. Line BC corresponds to EF. All right. So here's what I am going to do. I'm still going to find my missing side because I need to find out what that X is. So what I'm going to do is I like to write small triangle to big triangle. All right, I'm going to write small triangle to big triangle. So what do we have? On our small triangle, we have the sides 6 centimeters. Let me choose a completely different color. 6 centimeters. Whew. All right, and the side that corresponds to that on my small triangle is going to be line EF, which is X centimeters. And we're saying that that is equal to, well, let's see, my small triangle, 4 centimeters. And the side that corresponds to that is DF, 12 centimeters. Okay? So notice where I'm getting everything from. So I'm writing, my ratio is small triangle to big triangle. And then I am writing everything out here. So 6 centimeters to X centimeters is equal to 4 centimeters to 12 centimeters. Let's go ahead and let's use our cross product to find what X is going to be equal to. All right, what will that leave us with? It'll leave us with 6 times 12, which is 72, is equal to 4x. Divide 4 by both sides. We get that 72 divided by 4. And we'll find that 18 is equal to x. And when we say 18 is equal to x, then we mean that we're talking about 18 centimeters. All right. All right. Let's do the same thing with this bottom shape. Remember, rewatch these videos if you need to, okay? I'm going to do the same thing with this bottom one. Notice something about this. Notice how my corresponding sides are not in similar locations, or my corresponding angles, better yet, are not in similar locations. So notice that angle R, you would normally think that angle R would be corresponding to this angle right here. But notice the number of lines. So angle R does not correspond to angle X. Actually, angle R corresponds to angle W. So we have to be aware of that when we are writing down these corresponding sides in order to figure out the missing value. Okay, so be aware of that. Don't just blindly assume that this angle and this angle are corresponding. Okay, so we can't just blindly assume that. So we will watch out for what's going on here. Okay. So I'm going to do the same thing. This looks like, I'll call it a quadrilateral. So I'll say small quad to big quad. All right, so let's find those corresponding sides. So side RS does seem to still be corresponding to side XW. XW seems like it's just kind of flipped around. And side RU seems to correspond. It doesn't correspond to this side right here, so don't get tricked by that. But it actually seems to correspond to this side right here. Notice how I have a 3-line angle, a 1-line angle, a 3-line angle, 1-line angle. So those do correspond to each other. So let's go ahead. Let's write this one out. Let's do this. All right, so let's do my small quadrilateral. So I have D feet over 49 feet is equal to, so my small quadrilateral again, 4 feet, and that corresponds to 28 feet. All right, let's do this. Cross product. And let's do the math. So 28 feet, 28, I should say D, is equal to 49 times 4, break it out my calculator, 196. Divide 28 by both sides, and this should tell us what D is going to be equal to, and it tells us that D is equal to 7. And what are we talking about here? We're talking about 7 feet. All right. So there you go. Again, need further assistance, jot down whatever question you might have, bring whatever question you might have to class. We'll do more practice in class. You still stuck? Come to office hours. All right. I'm looking for some math people to come to office hours. All right. I tend to have some people coming to office hours and talking about, I don't know, like sports and stuff like that, which is fine. But come to office hours. All right. I'll see y'all tomorrow.